Alright guys, part 2. Using the secant line to find the tangent line. Well, in part 1, I kind of give you an idea of what we're trying to do here. We want to find the tangent line. In order to find the tangent line, we have to start off by picking our first point where we want our tangent line to lie. And then choose a second point a small distance away. And eventually we're gonna continue to pick the second point closer and closer and closer to the first point. See? So I pick a little bit closer, a little closer, a little closer, so close that they are eventually identical. Alright? Okay, so in the pictures above, notice how the point Q moves closer and closer to the point P. Okay, the distance between A and X, so here's the A, that's where we want to find our tangent line, and X is getting smaller, and the slope of the secant line are looking more and more like the slope of the tangent line that we are searching for. Okay, so this is really cool because now we get to define the method to find the slope. Okay, so check this out, guys. Okay, check this out. Another way for us to represent like the second point of the secant line is to say, okay, pick the first point at A, so let's call that A comma F of A, like that, right? And then we're just gonna say, okay, pick the second point a small distance away from the first point. And so we're gonna call that gap of distance, let's call it H. Okay, so pick the second point H units away from the first point. And remember that H is very small. If we were to do that, then the second point Q would have an order pair of A plus H comma F of A plus H. Now, don't get me wrong, if this is kind of confusing to you right now, it's okay. It's okay. Remember, you might need to watch this lesson a few times to really absorb everything that we talked about, because remember, calculus is a challenging topic and it takes mathematician a very long time to be able to kind of compile everything. So I don't expect you guys to get it in one lesson. Alright? Keep that in mind. But if you can understand that my second point is just a little bit farther away from the first point, and that gap of distance, we call it H, then we can express the second point as A plus H. Think of it this way. Let's say if A was 2, right? And let's say if this point is 3, then I can just go 2 plus 1. See, that's the 3. So that's another way to think of it, all right? This would be like F of 2, F of 3. So like 3, F of 3. So your H would be 1, right? And if you think about it this way, the distance between the first point and the second point is just 1 unit away, see? So if you know how far the second point is from the first point, then think of that as your H, okay? Awesome. Now, the secant line and the difference quotient in terms of H. So, if we express the 2 points in terms of H, then here is how we would compile the slope of our secant line. So our secant line would be like the change in the y value, right, over the change in the x value. That's how we would find the slope of the secant line. And remember that the slope measures the level of incline, right? How high it is or how low it is. So that's the slope. So then that red line that I just drew for you, the slope is a number, right? It's a number. If it's 0, then it's on a flat surface. And if it's 1, then it has a bit of incline, kind of like you're running on a treadmill. now we can think of the change in y as the change in the the change in the function, because this is the output, right? Y is the output, f is the output. So the change in the f function. This is the change in the f function. This is the change in y, or think of it as the change in f over the change in x, which is this length. So the change in x. All right. Now, what is the change in f? Let me write that down here so that there's more room. Well, the change in f is subtracting these two outputs, subtracting this output and that output. That's the change in f. Okay, so we go f of a plus h minus f of a. And then what is the change in x? Well, the change in x is subtracting this distance, these 2 points, or the distance is the change in x. And if you, okay, two ways to think of this. If you subtract these 2 points, you're going to get h. Or you can say, oh, that distance is h. Okay, so that's just h. All right, so guess what, guys? The secant line, when we express the second point in terms of h, or h units away, is just this. That's the secant line. Okay, and what we're going to do is, if we make h equal to 0, or I'm sorry, if we drive h close to 0, then guess what? If we drive h close to 0, then that means that these 2 points are going to be very, very close to each other. All right? And if these 2 points are really close to each other, then our point P, you see, derivative calculus is fascinating. That's why sometimes I have to like smile while I'm trying to explain these things to you. So if we drive h near 0, then this second point is going to be really close to the first point, and that's also another way to find the slope of the tangent line at a point. All right, so before we continue further, let me tell you that this formula that we just came up with is called, not the formula, but this slope of the secant line that we came up with is called the difference quotient. Okay, so let's write that down. So the difference quotient is this. That's the difference quotient. All right. Awesome, guys. Go ahead and go to the next part, and we're going to get right into the nuts and bolts of our lesson.